So I want to revisit the adversarial attack on sentiment analysis that we did in our previous step. As you remember, if we manipulate some spelling and some grammar on sentences as we pass them through sentiment analysis, we can dramatically affect what the result of the sentiment analysis result is. We can transition similar sentences from a positive to neutral to negative sentiment. So a small recap demonstration right here. We have a similar sentence where the original sentence is the top one right here. Misery was the best movie I've seen since I was a small boy. That's a positive statement, and so we have a positive predicted sentiment of 97%. Now, if we just misspell best and movie, we can change the positive sentiment to a neutral sentiment with the confidence score of 54%. If we add in a small grammatical error, we can transition the sentiment prediction from neutral to negative with a confidence score of 57%. And as we saw before, we can use CAPTM in order to understand how our sentiment analysis model came to that particular conclusion. So here we see a token level attribution for positive sentiment. Anything to the right of 0.0, which represents neutral, leads you to a more positive statement. Anything to the left, or that's a negative number for an attribution score, typically indicates a negative sentiment. So on the left-hand side, we can see Misery was the best movie I've seen since I was a small boy. And as you can see from the attribution score of the individual components or the individual words, this sentence came back as a positive sentiment. Now, if we go ahead and look at the token level attribution for our last sentence, which is the one that we transitioned from positive to neutral and finally achieving a negative sentiment, you can see we misspelled the movie best movie and we had the grammatical error since me were a small boy. And just based on the misspelling and the grammatical errors, we were able to transition and fool our sentiment analysis model to giving this a negative sentiment by shifting a negative attribution for a lot of the words in the sentence. This is done by misspelling words and thus confusing the sentiment analysis model in order to understand what each word represents within the given sentence. Now, how we go about defending an adversarial attack like this, where we're purposely misspelling words and introducing grammatical errors in order to give a false positive on the predicted sentiment, well, the answer is pretty simple. There are many different solutions that are available, but one of the easiest ones that you can do in this particular case is take the sentence and run it through a spell check and a grammatical check. 3 recommended tools that I would look into. The first tool to take a look at is Language Tool Python, which you see right here. Another tool to look into is Graphformer. And the last one that I'll mention here is PySpellChecker. Again, there are many other tools and methods in order to defend against adversarial attacks for NLP, so natural language processing type problems. I invite you to go ahead and take a look at the resources at the end of the presentation to look at other options that are available at your disposal. So for the demo here, if we're going to try to defend against that particular attack against our sentiment analysis model, the easiest thing to do is run a spell check against it. And hopefully we should arrive at 3 uniform answers, all with a positive sentiment with a high confidence. Let's go ahead and give it a try. So you can see here, the original text in the last case, this was originally predicted to be a negative sentiment. We ran it through our spell check and our grammatic check, which fixed the sentence into the intended sentence, thus yielding a positive sentiment with a confidence score of 98%. I hope you enjoyed that demo.